Alright guys, welcome to this page of the notes. What we're going to do is continue this discussion of a couple special cases of triangles. In particular, we're looking at the isosceles triangle, which we just looked at, and now we're going to look at the equilateral triangle. Again, I think many of you are already familiar with the properties of an equilateral triangle. Let's talk about them again just in case. So, equilateral simply means every side is equal measure, right? So that's what you guys probably are already familiar with. You have a triangle where all three sides are the exact same measure. But we can go one step further than that. We just talked about with the isosceles triangle, because two of the sides are congruent, that meant the two angles opposite those sides also had to be congruent. Well, check this out. Since all three sides of the triangle in an equilateral triangle are congruent, what do you know about the angles? Yeah. All three angles must be congruent. They have to be. That's the only way you can get three equal sides, right? The length of the side depends on the measure of the angle, right? If I were to make this angle over here, if I were to make this angle bigger, what happens to the length of this side? It gets longer. If I were to make this angle over here smaller, what happens to the length of this side? It gets smaller, right? The length of the side is determined by the measure of the angle. So, if all of the angles have the same measure, what do we know about all the sides? They have to be the same. And if all of the sides are the same, you know all of the angles have to be the same. Well, this makes things really, really easy, since the interior angles must sum to 180 degrees. Every angle is equal to 60 degrees. Right? It has to be. 180 divided by 3 is 60. 60, 60, 60. Equilateral triangle, equiangular triangle, all the angle measures are the same, happens to be 60 degrees. Now, with that information, we can do several problems. So let's go back to that problem on the previous page that I had to skip. Here it is right here. Let's give this one a shot. Now, here's what I know. First, I apologize. There is a typo in the diagram. I needed a little guy right there. Sorry, right there. Right? What that tells me, right, is all three angles are congruent. Now, if all three angles are the same, what do I know about all three sides? Well, thanks to equilateral triangles, I know that all three sides must also be congruent. And just like that, I see the problem I need. I know that this side is 6x minus 5. I know that this side is 4x plus 7. These two sides are equal to each other. So, set up your algebra problem. 6x minus 5 is equal to 4x plus 7. And just like that, we have a fairly simple algebra problem to solve. Subtract 4x to the other side, 2x. Add 5 to the other side. 12 divided by 2. How about 6? Now, plug and chug, right? 6 times 6, 36. 36 minus 5, how about 31? So the length of this side is 31, whatever, feet, meters, inches, whatever the units are, it doesn't matter. 4 times 6, 24. 24 plus 7, yeah, 31. But that's exactly what we expected. We knew that the length of all of the sides had to be the same. That one would be 31 as well. All right, I got a couple more for us here on this page right over here. So I go back to where we had our information about equilateral triangles. Go ahead, slide that guy on up. And let's do a couple more problems. I apologize, I am not sure where. I don't know why that red line is in there. Hopefully it doesn't bother you guys too much. Find the value of the missing side lengths or angles, or the value of the unknown, right? There's lots of ways that these could go. All right, here we go. Once again in the diagram, all of the angles are the same. So what do I know about the sides? Well, that tells me all the sides have to be the same measure. Well, we go ahead and set up our algebra problem. Here's the reason I like this one. Fractions. Now, generally, fractions kind of freak kids out. Please don't be freaked out. Fractions are not that scary. Let's go ahead and do this problem and I'll show you. We're going to have 3/10 y plus 9 is equal to 4/5 y minus 1. Okay, we need to solve for y. Yes, we have fractions. That is okay. Fractions are not that big a deal. Let's just work through it nice and slow. We'll see how this goes. First thing I'm going to do, it's a minus 1. I'm going to add that to the other side. 9 plus 1 is 10. That leaves me with 4/5 y. Now, I need to get the y's together on the same side of the equal sign. So, 3/10 y, I'll subtract it to the other side. Minus. Now, in order to subtract fractions, what must you have? In fact, in order to add or subtract, doesn't matter, we just happen to have subtraction. But in order to add or subtract fractions, you need the denominators to be the same. We say you have to have a common denominator to add or subtract fractions. I need the denominators to be the same. Well, in order to find your common denominator, all you need to do is find the LCM, the least common multiple of the denominators that you have. I have a 5 and a 10. What is the LCM of 5 and 10? Well, the least common multiple of 5 and 10 is 10. 10 is the least common multiple. 10 is a multiple of itself, and 5 times 2 is 10. So, I need my common denominator to be 10. Here's how we're going to do it. In order to turn this guy into a 10, I need this 5 to be a 10. I have to multiply it by 2. But algebra says whatever you do to one part of the fraction, you have to do to every part of the fraction. So, since I'm going to multiply the denominator by 2, right? 5 times 2 gets me 10. I also have to multiply the numerator by 2. If I'm going to multiply 2 in the bottom, I have to multiply 2 in the top. That's the way algebra works. Whatever you do to one side of an equation, you have to do to the other side of the equation. Whatever you do to the bottom of a fraction, you have to do to the top of a fraction, right? Algebra is all about equality, making sure that things stay equal. Everything stays level. Everything stays simpatico, right? If I put a 2 in the bottom, got to put a 2 in the top. Right? That's times y minus 3/10 y. Well, no big deal. 4 times 2 is 8. 5 times 2 is 10. So I have 10 is equal to 8/10 y. All right, well, now that I have my common denominator, right, 10 and 10, how do you subtract fractions? Easy. Subtract the numerators, keep the common denominator. So I keep the 10. 8 minus 3 is 5. So 8/10 minus 3/10 is 5/10 y. Now, I need to solve for y. Let me slide up a little bit. No, I don't want to slide up a little bit because that'll save my stuff. Let me come right up over here. So what I'm going to do, I have 10 equals 5/10 y, right? Now, how do I solve for y? You have a couple of options, right? Since I'm dividing by 10, multiply 10 to the other side. Well, 10 times 10 is 100. Right? Okay, awesome. I'm multiplying by 5, so divide the 5 to the other side, and we wind up with a y is equal to, what do we get? 100 divided by 5 should be what, 50? Sorry, 50, 20. 50. Jeez Lou. Right, 100 divided by 5 is going to give you 20. So now, all right, now that I know that y is 20, plug it in, right? Plug that 20 in for the y, and let's see what we get. All right, so I have 3/10 times 20 plus 9. Okay, here we go. Let's see, 3 times 20. 3 times 20 would be 60. 60 divided by 10, 6. 6 plus 9, about 15. Hey, that's really good mental math, guys. That's good. If you can do that in your head, fantastic. If you still need to use a calculator, okay, fine, use a calculator, but awesome if you can do that in your head. 3 times 20 is 60. 60 divided by 10 is 6. 6 plus 9, 15. Easy peasy. Go. Awesome calculator right here. Make sure you use it. Same thing here. 4/5 times 20 minus 1. Well, 4 times 20 is 80. 80 divided by 5, 17. No, 16. 16 and 16 minus 1, 15. Oh, I love it when a plan comes together. Awesome, so I get 15 and 15, right? Which I knew they had to be the same length. All right, I got one more problem for us, so let's go ahead and jump into that one. I'll do so by erasing this stuff so that I'm not getting in my way. Slide it over here. Okay, fantastic. All right, I want to find the missing value, which is this guy right down here. Okay, well, let's see how this goes. Here's what I know. I need to find x, but the only value they've given me is this angle way up here, 107 degrees. Okay, let's see what we can do with this. First, this triangle right here. Couple things about it. First of all, they tell me it's an isosceles triangle. 2 of the sides are congruent. We'll come back to that in a second. More importantly, what you should recognize is I have a triangle with an exterior angle. Oh yeah. Exterior angle. Well, what do I know about the exterior angle and its adjacent interior angle? They have to sum to 180. So I know that 107 plus something, right? I don't know what that something is. I'm going to find it. Has to be equal to 180, right? These two guys form a linear pair. They have to sum to 180. So subtract 107 to the other side. Guy, I don't know. I don't. All right, I'm trying to find it. So we get 180 minus 107. And that angle that I didn't know. What do I get? How about 73? 73 degrees. Okay, so let me write that. 73 degrees is that guy right there. Now, we come back to this idea that we just talked about. It's an isosceles triangle. This side and this side, right, are the same length. So what do we know about the base angles? Well, in an isosceles triangle, we know the base angles have to be the same measure. So this guy is also 73 degrees. He has to be. They both have to be 73 degrees. That's how an isosceles triangle works. Awesome job. Well done. Okay, well now, right, the interior angles of a triangle have to sum to 180. So let's do it again. We have 73. 73 degrees plus 73 degrees plus, I don't know. I don't know what that angle is, but I know all three angles have to sum to 180. Okay, well, keep going. What do we get? 73 plus 73. Add 73 plus 73, subtract it to the other side, and I wind up with that guy that I don't know is 34 degrees. So, 34 degrees, boom, is that angle right there, 34 degrees. Stick with me. Beautiful thing. Check this out. I have intersecting lines. What do I know about these two angles opposite each other when I have intersecting lines? Boom! Vertical angles. So, I know that this one is also 34 degrees, right in there. Why? How do I know that? The vertical angles. The vertical angles. What? Check this out. I have congruent sides. If these two sides are congruent, what do we know about the triangle? It's an isosceles triangle. Well, isosceles triangles, not only do they have two congruent sides, but the base angles also congruent. So what do I know about this angle down here? 34 degrees. Oh yeah. Look at that. Look at what we did. We started way up here with 107, using what we know about exterior angles, using what we know about isosceles triangles, using what we know about vertical angles. We've gotten all the way down to here. We have found everything except for, boom, right there. We need to find x. Well, I know the interior angles must sum to 180 degrees. So, last step, 34 degrees plus 34 degrees plus x has to sum to 180. All right. 34 plus 34, subtract it to the other side. 180 minus that guy, you get 112 degrees. Boom. Again, this problem, amazing. Amazing, right? Because in one problem, I'm able to figure out what you know about exterior angles, isosceles triangles, vertical angles, and that the interior angles of a triangle sum to 180 degrees. In one problem, I'm testing you on 4 or 5 concepts that we've talked about in geometry. I'm taking all of those ideas and packaging them in one problem. Magic. Just absolute magic. I love this problem. Trust me, if you're taking this class with me, you are going to see something like this a couple of times. Love these problems. So good. And not that difficult, right? As long as you know the properties and the theorems that we've been talking about all year, just apply them in the right way. You can work your way through this guy solving for all of the angles. Had a great time taking a look at this idea of isosceles and equilateral triangles with you. Thank you so much for joining me. I'll see you guys next time.